So if we let y equal the inverse sine of the square root of 1 minus x squared, then the sine of y is square root of 1 minus x squared. If we differentiate the left-hand side, we get cos y, and we have to remember to multiply by dy dx. And if we differentiate the left, first of all, we've got to think of this as 1 minus x squared to the power half. We bring the half down, we multiply by the function differentiated, so that's minus 2x. Then we have our bracket and we take away 1 from the power. So we now have that cos y dy dx equals minus x upon 1 minus x squared to the power minus 1/2. So cos squared plus sine squared is 1. So the cos of y is the square root of 1 minus sine squared. But we can see from our line here that that is the square root of 1 minus x squared, which is going to be the square root of x squared, which is going to be x. So x dy dx equals minus x over the square root of 1 minus x squared. So dy dx will be minus 1 over the square root of 1 minus x squared. So y equals the inverse tan of sinh x. So tan of y equals sinh x, and if we differentiate the left-hand side, remembering to multiply by dy dx, and if we differentiate the right-hand side. Left-hand side we can rewrite as 1 plus tan squared. And 1 plus tan squared is 1 plus sinh squared. Cos squared minus sinh squared is 1, so 1 plus sinh squared is cos squared. So if we divide through, we end up with 1 over cos. So dy dx is the inverse, so that is... You can see that the first solution offered in the mark scheme is not the way that I have done this question. It is in fact what they describe as the alternative solution, is the way that I've shown you in the notes to approach this type of question.